here's a new set of identities called the power reducing identities. And they're useful sometimes. They're not one of the more popular ones, but they are useful in cases where I don't like having a squared value. And I want to reduce that square value to sine, cosine, or tangent functions that don't have any squareds in them at all. You can actually do this using the double angle identities. There's a special double angle identity, cosine of 2a. It's going to come in really handy for us. So I'm just going to copy those identities, bring them down here so we can use this. Okay? And in particular, I want to use not cosine squared of a minus sine squared of a, although that might be the one you remember most easily. I want to use these guys right here. Cosine squared equals 1 minus sine squared, and cosine squared equals 2 cosine squared minus 1. Now, if you look back and forth between the identities right here and the ones we're trying to find, you might be able to notice something. There's a cosine squared in each case. Specifically, specifically right here. See that cosine squared? So let's play around with that a little bit, and we're going to see if we can solve the cosine squared case. This says cosine of 2 times an angle equals 2 cosine squared a minus 1. Well, if I just rearrange this a little bit, what do I get? Cosine of 2 times an angle plus 1. Okay, so that's right there. And then on this side, on the right side, I still have 2 cosine squared of a. Well, how about I divide each side by 2? So what do I get? Cosine of 2a plus 1, all divided by 2. That's what cosine squared reduces to. That we would say this is the reduced form of cosine squared. It's cosine 2a plus 1 all over 2. So that's cool. That is our cosine squared power reducing identity, which we would put right here. Okay, that's our answer to that one. But we also have a sine squared identity. If you look right here, there's a sine squared formula, and it's going to go exactly the same way as I just showed you for cosine. So let's use another color here. I'm going to say cosine of 2a equals 1 minus 2 sine squared of a. And then we're going to rearrange this a little bit. I'm just going to add 2 sine squared of a over to the left and bring the cosine of 2a over to the right. Okay, I think it'll be a little easier to talk about this way. And now I just divide each side by 2. So I get sine squared a equals 1 minus cosine 2a, all divided by 2. So that's our sine squared power reducing identity. And you would put that way up top where it's asking for sine squared right here. Okay. Now you might think we're going to go do the same thing for tangent squared, same pattern, right? But I actually prefer a different way of doing this. First of all, notice that there's no tangent squareds in here. So the same idea is not going to work quite like it did above. I need to move you, Mr. Unit Circle. So you go live over here for... Oh my gosh, that looks terrible. Hold on. Okay, here's what we're going to do. It's margins time. I'm just going to work in the margins over here, okay? The question is, what is tangent squared a? Well, we could use the quotient identity to say that's sine squared a over cosine squared a, right? And if I know sine squared a and I know cosine squared a, we could just divide those two. So tangent squared a is going to be, and bear with me here, 1 minus cosine of 2a all over 2. And it's that thing divided by 1 plus cosine of 2a all divided by 2, right? Now, those divided by 2's are going to cancel out. If you do your keep flip change, you're going to see some things cancel out, and yada, yada, yada. Here's what we get. 1 minus cosine 2a over 1 plus cosine 2a. Okay, that is our tangent squared identity.